Perfecto, entonces iniciamos. Nuestra siguiente expositora es Garance Upham, presidente de la ONG Discapacidad y Círculo Económico, Movimiento para la Salud de los Pueblos. Garance es economista, investigadora experta en prevención nosocomial, activista por el derecho a la salud. Ha trabajado en la salud mundial durante más de 30 años. Construyó los primeros programas de prevención del SIDA en la África subsahariana en los años 80. En 2004 se incorporó al Comité de Dirección de Pacientes para crear la Alianza Mundial de la OMS para la Seguridad del Paciente. Participa en el movimiento de salud de los pueblos para defender sus derechos y promover la protección social universal. Garance ahora nos presenta el tema La era Post-Antibióticos, un acercamiento ecológico a la resistencia bacterial a los antibióticos, el final del sistema de derechos de la propiedad intelectual. Garance, welcome. Can you hear me?
Thank you very much for inviting me. This is wonderful. I hope the technology works well. My talk will cover 3 issues as indicated in the title. The first one is that we have entered an era in which antibiotics do not work anymore. The second one is whether we can have an ecological approach to bacterial resistance. And the third one is the effect on the intellectual property rights, though I will speak about IPR first. Now, if we, next slide. The next slide. Okay, thank you. Now, if we look at the situation today, the situation is one of overconsumption of antibiotics over the past 50 years. It's been massive, it's been unchecked, irresponsible use. It's been irresponsible use in human medicine by family physicians. About 80% of antibiotic use in Europe is not needed. There's overuse in prophylaxis in hospital. There's overuse in prophylaxis in animal breeding. In industrial farms, if you have 5,000 chicken and 1 chicken is sick, you give antibiotics to all the animals. This is very convenient to industry because antibiotics are a growth factor for animal breeding. It makes the animal fatter, faster, so it cheapens the cost. And it is also, antibiotics are also used on fruits and vegetables, including organic fruits and vegetables. In the United States today, in 2013, over 70% of antibiotics is used on animals. Next one. Next slide. Thank you. So this is a slide presented by the World Health Organization in a patient safety meeting in 2009. And it comes from, as you can see, a Washington Post 2005 articles in the US press. It talks about overuse of antibiotics in the United States of America. And you can read the slides. It is stated that over half of the antibiotics is used in animal feed. 80% of the use of antibiotics has been employed to make animals grow fat faster. You know, and then we're surprised there's a problem with obesity among humans. Anyway, so you can see the amount of tetracycline and streptomycin used in this period of time. And you can see there is overuse as well in fisheries and salmon. Next slide. Next slide. Okay. So there's been this overuse of antibiotics, and the consequences is that there's a loss of efficiency of all antibiotics in human medicine. There's a rise and the spread of bacteria, which is resistant to everything in wastewater, in groundwater, and over-the-counter sold meat. It's 50% of all meat sold in the supermarkets have bacteria that is resistant to everything according to the US Food and Drug Administration. So because of that, because we find multi-drug resistant bacteria in the water supply, in water resources in states of America, as well as in the water supply in India. So it's really a global phenomenon. We have found it in the Lac Léman in Geneva here. So because of that phenomena, the spread of resistance is global, it's worldwide, it's intense. And the phenomena of resistance is increasing very dangerously because of recombination of dangerous bacteria within our own intestinal flora, which is called the microbiota. So there is a spread today of MRSA, C. difficile, E. coli, and other bacteria in healthcare, but also in the community, in schools, which is leading to millions of patients being hospitalized, is leading to death in the community. And what is on the horizon today is really the spread of untreatable diseases. Diarrhea, tuberculosis, that's totally drug resistant. The experts, the scientists are saying soon, within the next 5 years, all surgery may be impossible. Next slide. There is nothing in the pipeline. We have entered the post-antibiotic era. So I participated in a meeting of scientists. I was the only non-scientist in the room because I don't work in a lab. And that was a meeting in 2011, just 2 years ago, organized by Biomérieux. And what the experts said is that we are entering a world with no antibiotics, where no antibiotics will work, which is extremely, extremely dangerous. Now, this year we had the English government saying that antibiotic resistance is on the same level of priorities as climate change or terrorism, which is to tell you that the richest countries are considering antibiotic resistance as the #1 item on the agenda. We have to realize that the number of new antibiotics put on the market by the pharmaceutical industry has declined dramatically since the 1980s. Industry admits, and I've gone to meetings of industry, that there is nothing new coming. The pipeline is empty. There are no new really effective antibiotics coming online. There are no new products being under clinical testing now, which we could say that they would bring a solution tomorrow. And we have, just in the United States of America, several million patients hospitalized every year, even in rich countries, with infections due to antibiotics-resistant bacteria, and that in the tens of thousands. If we have a unchecked rise of antibiotic resistance, and hospitals may be dangerous to your health. Now, rich countries and multinationals are advocating public-private partnership, and we will see in discussing intellectual property rights why, in my opinion, this is not the way to go. Next one. Next slide. We have epidemics of tuberculosis and diarrheal diseases on the horizon. I used to work with the International Union Against Tuberculosis and Lung Disease in a partnership with Stop TB of the WHO, and followed the situation over the past 10 years. Over the past 10 years, we have gone from multi-drug resistant tuberculosis to extremely multi-drug resistant tuberculosis. And now we find in countries all over the world totally drug resistant tuberculosis. It's notably been identified in India recently with the visit of people from the French parliaments. And Professor Tim Walsh, who has worked on the problem of genes of resistance to antibiotics present in bacteria in water supply in India. He's saying that bacterial genes of resistance entering the human gut creates extravagant opportunities for new totally resistant bacteria spreading diarrheal epidemics. Next slide, please. Okay, this is another slide from a WHO presentation, and you can see that there are 5 key areas for containment of antimicrobial resistance. And those are things that every country has to do. One is infection prevention. We must have clean hospitals. This is very important. Let me tell you in passing that I was in a conference recently, a global conference in Geneva, on prevention of hospital-acquired infection, so in hospitals. And somebody reported from a big, very modern hospital in Australia that the only way they were able to cut down on infections due to multi-drug resistant bacteria was by cleaning the entire hospital with bleach, just ordinary bleach. Every other very modern aspect of infection control was done, but it was cleaning the whole place with bleach, which was found to be most effective. So that's one thing. As you can see, rational drug use and regulation is another key aspect. We can no longer accept that antibiotics for human use be used for hospitals, be used for animals. This is a really important issue, and every country has to have very tight regulation on the use of antibiotics in individual medicine, in hospitals, as well as for animals. Research and development, we'll talk about that later. And of course, animal husbandry. Next one. I belong to an organization that's French-based, which is also global, called World Alliance Against Antibiotic Resistance. And what we recommend is notably natural ventilation in hospitals. There's a memorandum that was published some years ago in the WHO on that. We need to put emphasis on water and waste management to make sure that multi-drug resistant bacteria does not get into the environment. And another thing for developing country, we have to make sure that food products entering the country are not contaminated with these bacteria. So we need to have more testing, more diagnosis. And the war recommendation are that we need to have restriction on antibiotic prescribing. For example, for otitis, ear disease in France, we know there's about 6 million prescriptions a year, and only 2 million of those are needed. In other words, the other 4 million are earache and throatache, which are of viral origin. And when you do the laboratory testing, you find there's no bacteria. The problem is the public has been accustomed to thinking that antibiotics is a miracle use. It's a miracle drug. And if your child has a throatache, quickly antibiotics. And you put pressure on the physician to give antibiotics, while the pharmaceutical industry puts pressure on the doctor to prescribe antibiotics. So we have, just in my country, tens of millions of prescriptions of antibiotics a year in France are totally unwarranted and should never have happened. We have to forbid growth enhancers in husbandry. There is a fun story. There is a recommendation that's just been published by the Food and Drug Administration in the USA, saying that growth enhancers, in other words, antibiotics to animals to make them grow fat faster, should be stopped. But the FDA puts that forth as a recommendation and not as an order. The problem is if you don't have any enforcement in the back of this, then do you imagine industry will comply? No. If a firm complies, if a firm will not comply if the other firms don't comply. So you need regulation by the state, by the government. If you don't do that, you're not doing anything. We need control by pharmacists, and we need to go over the conflict of interest. In many countries, veterinarians Next slide. Okay, then we have this situation in which antibiotics are no longer working. Now, I want to go into the other aspect of the consequences of that, which is that it is challenging the intellectual property system. And I will show you actually the latest pronouncement of the past 3 months. The World Health Organization has moved towards saying that the IPR, the market, does not work. So Margaret Chan here, this is July 5th, so this is just 2 months ago. She said, we have entered the post-antibiotic era. Industry has nothing to offer. We must consider new intellectual property models. This was a meeting of the World Health Organization, the World Trade Organization, and the World Intellectual Property Organization. It was reported in the Swiss press, but the official account of that meeting on the web does not mention that, but it was in the Swiss press and not just that newspaper, Le Temps. Another reference is Professor John Arne Rodigan, whom I interviewed. As you can see, he's chairman of the advisory panel on funding and coordination of R&D. It's called the CWG, which was an initiative taken by all the governments, members of the health organization in the WHO, including the Ecuadorian government. So what it says is that the linking between innovation and product prices applies to neglected disease and is also relevant to the problem of antibiotic resistance. And I read him, the public health perspective would be that there is a need to have restricted use of a new antibiotic so it can be effective for a long period, also long after the patent has expired. This speaks to the need to delink the cost of R&D for antibiotics and their sales. And in my opinion, delinking is one of the preferred option. Next one. Next slide. I will quote from Mary-Paul Keeney. Mary-Paul Keeney is Assistant Director General in the World Health Organization, and she is also the person in charge of antibiotics resistance of that particular domain, as well as others, patient safety and others. But she's in charge of antibiotics. And what, in my view, was great for all of us who have been raising questions about the intellectual property model as regards access to medicines for developing countries. What was great in her speech is that she made a link between the disease of poverty and antibiotic resistance. Well, that's what she said. The title was How to Discover, Develop, and Deliver New Health Technologies Equitably, a solution where there is no market. In the current context, we are used to hearing this framed with respect to low-income or developing countries. She mentioned the CWG, the World Health Assembly, the WHO, and she went on. However, she said, I want to highlight that in the health sector, it is not just poverty that leads to market failures. Let me explain. In health, the market can fail to deliver new health technologies for 3 reasons. When the potential market is too poor, disease of poverty, But there are two other areas, she said. One is where the potential market is too small, rare or orphan disease, where a small percentage of the population is affected. Next slide. And she said, she went on to say, my final example is a real killer. She said there's also another situation where the market fails because there is no market. My final example is a real killer, antibiotic resistance, and it is an example where there is no market, as the product has a shorter life cycle than the time taken to develop an alternative. At that point, Maya Potlini dropped her written speech and she said, in the case of antibiotic resistance, the use of the market is not desirable. Okay, we know that you can read on the slide the rest what she said, right? The result is no new antibiotic entering the market for 20 years and few in the current pipeline. Therefore, it will have to be a public good approach that is needed to prevent all of us from falling back to a public health status of pre-20th century where even a minor infection could be life-threatening. And I put you the reference to her speech, which was April 24th, 2013, at the Graduate Institute. So this is a speech she made in public. Though the sentence, in the case of antibiotic resistance, the use of the market is not desirable, she said to the audience, it was not in a written speech. But it is key. Why? Because, as you know, as Ecuador know, there is a lot of resistance because of a certain lobbying force in rich countries. There's resistance to rethinking the intellectual property regime. And yet, when we look at the major threat that is represented to human health globally of antibiotic resistance, we see that in that one case, which concerns everybody on Earth, we have to change the intellectual property system. The old intellectual property system does not work and needs to be completely transformed. And if it is transformed for antibiotic resistance, then it will also be transformed for disease of poverty or orphan diseases. Next one. Next slide. Okay, an alternative opposite approach. So there are two things going on today in terms of IPR and antibiotic resistance. There are many initiatives to maintain the market. To pretend the market still exists, even though Kini and many others individuals have said, well, where's the market? There's no market. New antibiotics, if any new product is online, it needs to be kept for emergency cases. If we use it right away, it will become obsolete. And we're in a situation in which all antibiotics become obsolete. So, but there are a lot of people who want to maintain the market. One thing to do is advocacy for longer-term patents. Advocacy to install extremely high prices on antibiotics. And of course, they push and pull patients' organizations to adopt these two alternatives, quote unquote. Then there's advocacy for public-private partnership with the public financing the private sector R&D. There's pull and push from state governments and regional funding bodies like the EU to adopt this kind of approach. And of course, the problem is that we also have the interests of the meat industry and the pharmaceutical companies' interests coincide and to go against the restricted use of new antibiotics. And that's one of the problems. We'll go to the next slide, please. Alternatives that I think we should favor go along the line of Keene's statement, the market is not desirable in the case of antibiotics. It means advocacy, doing advocacy for publicly funded R&D, advocacy for knowledge sharing, pull and push patients' organization to adopt these two alternatives, and I would say especially advocacy for price mechanism, pull and push state governments, regional funding bodies, Congress to adopt this. Price mechanism would reward both public and private R&D innovations. It has been advocated by the Nobel Prize in Economics, Joseph Stiglitz, in the press, in the US press, in the European press. There's an NGO, a non-governmental organization called Knowledge Ecology International, KEI, which has advocated for prices globally. And the interest of that is that if a private company came up with the new antibiotics, then the company, again, whether public or private, would receive a publicly funded prize for innovation, but then the antibiotic would be unrestricted on the market. It would be subjected to the regulation of the state and not be delivered with a profit motive. Because you see, the industry makes more profit today on what's called non-communicable disease or long-term diseases or HIV than on antibiotics, which is one of the reasons why we have no new products for the past 20 years. The next slide, please. Next slide. I wanted to say something quickly about non-communicable diseases, because I think it is a matter of concern that the resolution and the approach to non-communicable diseases within the WHO, in my view, in my own personal view, really speaking as a person and not representing an NGO or whatever, but I think that the resolution on non-communicable diseases is really questionable. It's questionable because fundamental research over the past few years have shown that NCDs have many bacteria, for more and more of them have either bacteria or viruses as the cause of the disease. We are finding, for example, that bacteria in the gut is responsible for obesity. So even obesity can be transmitted from mother to child or from a child to the family. Diabetes type 2, cancers, even hypertension, even mental illnesses. There's a huge program to study the relationship between the microbiota of the intestinal flora, the bacteria we all have in the intestines, and diseases today. And the problem is that if we treat all the disease, heart disease, diabetes, obesity, etc., as long-term pathologies, then we approach them as pathologies in which we have lifelong treatments, as in HIV, lifelong treatment. And the problem is the approach is one, it fits with the interest of delivering lifelong drugs to patients in some instances directly. We have Nokia, many telephone corporations are in the new approach to NCDs called the NCD platform. And I think it could be questionable because it ignores the outcome of the fundamental research. And in saying that the global burden of disease and the situation today makes NCD a priority, we can question that because, in fact, there's a threat of massive epidemics from bacterial resistance. So the danger globally to world health is not really heart disease or obesity, it's much more bacterial resistance. Next one. Now, in the next 10 minutes, next slide, I would like to speak about an ecological approach to the situation. As I said at the beginning, we have bacterial genes of resistance entering the human intestinal flora. It enters our body when we eat raw meat, or if we touch raw meat with our fingers preparing it and it has resistant bacteria, we get contaminated through the water supply. There's a big problem in India, which the international community or Indian government, I mean, some are reluctant to talk about it because there's a lot of development of medical tourism. So there's a conflict of interest there. But the approach should be to really try to improve waste management and water management if we don't want human beings to become contaminated and to spread bacteria that's resistant in turn. Now, if we take an ecological approach, there are many ways to take an ecological approach, and one thing I want to talk about a little bit is phages. But phages is not the only one, and I just came across recently, for example, that we have epidemics in the Americas everywhere of C. difficile, which is a bacteria that gives very severe diarrhea and kills notably old people in hospitals. And scientists have very successfully experimented a natural method to treat C. difficile with fecal infusion. They empty the bowels of the sick person and transfer the flora of a healthy person in its place. And so far, there's been limited experiences, but with 100% success. So this is very interesting. Next slide, please. Now, I want to talk about phages, or bacteriophages. Phage therapy may not be the only answer to the problem of antibiotic resistance, but it is an approach to research that is very accessible and quite promising for any country, whether rich or poor. It's at the frontiers of new knowledge today. We have to know that the number of viruses on Earth is estimated at 10 to the power 31, a large majority of which are bacteriophages, in other words, viruses which attack bacteria. We can easily find phages everywhere, in water, in feces, obviously in sewers, wastewater. Wherever bacteria proliferate, you find viruses that can attack those same bacteria. Next slide, please. A few words on history. It was Félix Derel who first performed research on ecological management of plagues in Latin America, notably in Argentina, in the control of locusts. And after having discovered that, he worked on the disease of agents of disease and found a phage at the time that you couldn't really see a virus because we didn't have the microscope powerful enough to see a virus at the time. So he discovered that a little bit through hypotheses and experiments, and he proved that there was a microscopic entity which he called a phage, which was a natural enemy for each species of bacteria. Next slide. This is a picture of the infection cycle in the bacteria. The writing is in French. I don't know if you can see it. On the left, you see what the phage looks like. It's a typical virus, in fact. It's a virus typical to the bacteria. But in terms of its size compared to the bacteria, you see it down on the right with little dots. That's what it really looks like in terms of proportions. So it's extremely small in relation to the bacteria. Once you have anyone has a bacterial infection, the phages begin to proliferate. And actually, if the process of getting cured from any disease that is bacterial in origin involves the virus of that bacteria. So the idea of phagotherapy is actually to multiply the phage, isolate and multiply the phage population so that those viruses will attack the bacteria that are responsible for the disease. Next one. Next slide, please. This is contemporary. This is a picture of phages. Next one. Next slide. Okay. Phage therapy had disappeared in Western Europe with the advent of antibiotics. The Pasteur Institute even destroyed its important collection of phages. But the work continued in Georgia and in Poland and a few other places. Okay, with the advent of antibiotic resistance and the end of the Cold War, the US and Europe gradually rediscovered phages. And phage therapy returns to the scene since the late 90s, especially in the year 2000. Next one. Next slide, please. Okay, what are the advantages of bacteriophages over antibiotics? The advantage is that it's biological control, I would say. It targets a specific disease-inducing bacteria. It does not affect good bacteria. If you take regular antibiotics, you know it destroys the intestinal flora for some time and has a lot of side effects, very bad side effects, which a phage therapy does not have. It can also be used to enhance the effect of antibiotics. It's been used that way today. It can be used to decrease the capacity of the bacteria to build resistance to antibiotics. It does not perturb the microbiota, the intestinal flora, unnecessarily. It can be used for disinfection in hospitals, healthcare settings. It's not being used today in Russia. It can be used for disinfection in the hospitals. It can be used as prevention. Advanced biotech is creating a biofilm based on phages. In other words, it's sort of a solution of phages which you will put on a surface and which will prevent the bacteria from creating their own bacterial films on things in hospitals and elsewhere. And it has proven efficiency against drug-resistant urinary infection and MRSA. Next slide. Next slide, please. Okay, there are different types of phage therapy. One is a cocktail of phages, which are produced and sold in pharmacies, for example, still today in Georgia. You have, if your kid has symptoms of pneumonia, you can go and buy it in the drugstore. And the cocktail of phages were used in the 1940s by the Soviet army as well as by the German army to reduce the risk of diarrhea for soldiers in the war, during the war. And then you have cocktail of phages that can be used in an individual, most individual therapy based on cocktails. It's more efficient than to have one phage against one bacteria. It's more interesting to have a cocktail of phages to use against an infection once you have identified the bacteria involved. Then you can have also specific phages which are individually collected from a patient suffering from a bacterial disease and cultivated to manufacture a treatment that is specific for him. The treatment requires a culture of bacteria from a wound that does not heal. For example, a wound with MRSA on an individual, and then identification of viruses attacking these specific species. Next slide, please. Next slide, please. There seems to be a delay, I'm sorry. Okay. So forgotten phages are making a comeback. Again, the Pasteur Institute destroys culture of phages because one thing that you need to know is if Ecuador decides to go in that direction, is that it's important to have today to set up cultures of phages, to collect as many phages as possible, different types, and to cultivate them and keep the cultures, because then they can be of use for treatment. We'll go next one, please, for time. Next slide, please. It's slow. Okay, phage therapy in France, just a few words, you can read it. There's a group of physicians who are organizing seminars on phage therapy. They are fighting to get the prescription of phages to become legalized in France. And what is very interesting, in the Pasteur Institute, there is a applied research project where they're using phages to treat lung infection in patients with cystic fibrosis. This is funded by the Association of Cystic Fibrosis Patients. And it's very successful so far. Besides Georgia, is also institute in Poland with the addition of phage therapy. Next slide. Next slide, please. Oh, sorry, I don't hear you. I can't hear you. Can you hear me? Okay. Yes. Yes. Okay. You cannot hear me. Okay. So I'll yeah? We can continue. Okay. We'll go next. We'll go fast. Tell your team we'll try to skip a few slides because we are losing time. So next slide. Next slide. Okay. Well, this is things I said before. In general, in clinical treatments, it is necessary to diagnose precisely which bacteria is responsible for infection, to control the effect of the phage preparation on the bacteria, to use a mixture, a cocktail of phages, and in use other than individual treatment, for example, in trying to control wastewater or sewers, water supply, You have to be careful, as with any manipulation of live elements in nature. Next slide, please. I wanted to say that today and always, the military has always been interested in phage therapy. For example, there is a very big research project funded by the European Union we call PhagoBurn, which is coordinated by the French Armed Forces with 6 international centers for burn wounds, that is experimenting with treatment of severe burns with phages on soldiers returning from Afghanistan. It was military funding which permitted the rehabilitation of the Institute for Fish Therapy in Georgia. It was NATO and US defense program. The information is public. I'm not revealing anything. It was written in the New York Times in May 2007 with an article entitled "Studying Anthrax in a Soviet-Era Lab with Western Funding." I recommend you read the article. You can find it on the web. The USSR had kept open its phage research throughout the post-war years in a Cold War context. It was protection from natural or man-made biological threats. I think today it's always an interest on the military side for that reason. It's protection against natural or man-made biological threats. And since the end of the Cold War, there's been an exchange in public interest in phage therapy research with rapid expansion of research since the year 2000. Next slide, please. Next slide, please. Let's skip that. I've got no time. Next slide, please. Okay, this is very difficult to read. I'll just tell you a few words about it. It's a listing of firms, notably innovative firms, and what they are doing. So you will be able to read it afterwards. There's Omnilytics in the USA, for example, the www.phage.com, which is treating bacterial disease of tomato with phages. Then you have control over chicken feed by a Korean company called CGCOKR, and so on and so forth. So you have basically hundreds of companies and startups who have been doing research on phages for food, food infection, animal infection, disease of fruit and vegetables, as well as human diseases or disinfection. So the list will be available. Next one. Next slide, please. Okay, I will end with that. What to do? I think there is an element that is very important, which is research. It is, in my view, very important, as Latin America is not very present in the field. It is important to develop one's own capacities for research on phage therapy and cultures of phages. In terms of policy, there's the importance of global awareness on IP dimension. I know your superintendent is very keenly aware of that. Pedro Paris, I've had the pleasure of meeting him in Geneva. He's very aware of the IP dimension in the threat of global epidemics. I think we have to use the fact of this emergency, the end of the antibiotic era, to help push forward the IP agenda. We also have to be, as governments, we have to be aware of the patenting of live organisms and be against that. And there has to be a lot of testing and surveillance, including on imported food. Next slide. Next slide, please. What more to do? I just put ideas in my own participation in the journal that I helped launch called World Health Observatory and the Geneva Health Forum platform. Briefings and side events. I'm in Geneva. We could do, Ecuador could organize technical briefings with other governments at the executive board of World Health Assembly to bring together developing countries on this issue. Re-evaluation of the resolutions on the NCD disease. I talked about it earlier. And perhaps placing antibiotic resistance and question for IPR systems in the subject matters of World Health and Social Security, which I'm told your government is preparing for 2014, late or early 2015. I thank you very, very much, and I'm sorry, maybe it was too long. I'll take your questions, and thank you again. Bye-bye.
Agradecemos a Garance Upham, que nos presentó el tema la era post-antibióticos. Si tienen ustedes alguna pregunta, por favor.